So the next part asks us to run insertion sort, and it gives us the same question. But now we're doing insertion sort instead of selection sort. And I like to think of insertion sort as sort of like a blob-like sort. You have like this blob and it expands along, starting from the left to the right, and whatever's in the blob has to be sorted. So like if the blob expanded here, it would have to swap 2 and 4 so that it would be sorted, so that would be like one swap. So here, and I can actually show you that right here. Notice how 2 and 4 are swapped because the blob, which was originally just 4, now expanded to be 2 and 4. And if the blob is 2 and 4, everything in the blob has to be sorted at all times. That's like the invariant for insertion sort. Then we expand the blob to take on 1, and when we take on 1, we're like, well, 1 should be before 4, so that's another swap, right? So that would give us 2 swaps, and we swap it 1 and 4, but we'll notice that the blob is still not sorted because 1 should be before 2. So we have to do a third swap. We have to swap 1 and 2. And after swapping 1 and 2, we can see our blob is finally sorted. Yay! But now we expand on to take 7, and we'll notice that 7 actually doesn't require any swaps. Because 7 is already sorted, it's in its correct position. 7 should come after 4. So we actually stay with 3 swaps. And we just include 7 in our blob. And then we expand our blob to take in 3, right? We're like, okay, I'm going to take 3 in now, but 3 needs to be swapped to its correct position. So we're first going to swap 3 and 7. So now we have a fourth swap. Now we increment it. We didn't increment it before because 7 didn't get swapped because it was in the correct position as soon as it joined the blob. But 3 is not in the correct position. 3 is less than 7, so it should be before 7. So we swap it over. But we'll notice that 3 is still not in its right position in the blob. 3 is less than 4, but it comes after it. That's an inversion. We can't have that. So we need to do another swap. And this will be our 5th swap. Keeping track with tallies here. So that's our 5th swap. And we'll swap 3 and 4. After swapping 3 and 4, we'll notice our blob is finally healthy to go. Everything is sorted in there. So then what it will do, as like by construction, we know that everything in it there is sorted. So the question is like 3 is now, like the element in front of it is 2, which is less than it, so we know we're good to go. You don't need to check the entire array with insertion sort, you just need to check the element you just added, which was 3. And 3, we swapped it with 4, but after swapping with 4, it's finally good to go, because 2 is less than it. Before, 4 wasn't less than it, that's why we required a swap. So now that we're good, we can finally expand. So we can take in 6, and you'll notice that 6 should come before 7, and that will give us our 6th swap. So we have 1, 2, 3, 4, 5, and this is our 6th swap. And with this 6th swap, we swap 6 and 7. And in swapping 6 and 7, you'll note that we have reached the answer to our question. We asked after how many swaps does 6 first go in front of 7? Well, this is the first time 6 went in front of 7. 6 was always like in this position, and like the first place where these two intersect was right here with the 6th swap.